come down the waterfront to see these submarines being built. It is truly
A new apex predator is in the water. The U.S. just deployed its latest submarine, and the details are sparking serious fear. Many people are crazy about its size, but that's not the scary part. It's the silence. This machine is built to be a phantom, a deep-sea secret that can't be found. The stealthiest submarine that the U.S. Navy has ever produced. We're pulling back the curtain on the technology that makes it invisible in the terrifying arsenal it carries. What many overlooked is the other secret sub-program, the SSNX, that's coming right behind it. Columbia's terrifying secret. Imagine the Empire State Building. Now lay it on its side and slide it under the Atlantic Ocean. Do it without making a sound, without a splash, and without a single wave. The ocean just swallows it whole. In the quiet that follows, the single most terrifying machine ever built by humankind begins its patrol. This machine isn't built to fight a war, it's built to prevent one, simply by existing. Because the threat it carries is so total, so final, it makes the idea of a large-scale conflict unwinnable. This is the USS District of Columbia, the very first of the brand-new Columbia-class ballistic missile submarines. And to put it mildly, it is a ghost that carries thunder. For decades, the United States has relied on its Ohio-class submarines. These were the ultimate Cold War deterrent, silent and powerful. But here's the thing, they're getting old. They were built in the 1970s and 80s, and they're reaching the end of their service lives. More importantly, their nuclear reactors need a complicated and expensive checkup and refueling about halfway through their life. This midlife makeover takes the sub out of the water for years, leaving a hole in the nation's defense. The Navy knew it needed a replacement, but it didn't just want an upgrade, it wanted a leap. The result is the Columbia class, and the numbers are just staggering. This isn't just a warship, it's a moving underwater fortress designed to stay hidden for months at a time, completely ready to act. She weighs in at over 20,000 tons and is 560 feet long. That's almost the length of 2 American football fields. Her width, or beam, is 43 feet. This makes her the largest submarine the United States has ever even tried to build. The price tag matches the power. The lead ship, the District of Columbia, will cost about $18 billion. Each of the 11 sister ships after her will cost around $11 billion. To build something this massive, the Navy had to turn to its 2 most famous shipyards, General Dynamics Electric Boat in Connecticut and Newport News Shipbuilding in Virginia. It's a team effort. Each yard builds huge, complete sections of the submarine, which are then floated to one location and joined together like the world's most complicated and high-stakes puzzle pieces. But the real wow factor, the part that has other countries terrified, is deep inside its hull. At the heart of the Columbia is a brand new S-1B nuclear reactor. This reactor is a marvel. It is designed to power the submarine for its entire service life. We're talking more than 40 years without ever needing to be refueled. Think about that. The Ohio-class subs had to come home for years. The Columbia never has to. From the day it's launched to the day it's retired, 4 decades later, its power source, good to go. This single change dramatically increases its availability, saving an estimated $40 billion in support costs over the life of the fleet. But the reactor's lifespan isn't even the scariest part, it's how it uses that power. You see, this reactor creates a massive amount of steam, which spins turbines. In older subs, those turbines would connect to a set of massive, complicated reduction gears that would then spin the propeller shaft. Those gears, no matter how well made, clanked and whined. That gear noise was the sub's fingerprint, the sound enemy sonar operators would listen for. The Columbia has no gears. It is the first American boomer to use a full electric drive. The nuclear core's turbines spin a generator, creating a massive amount of electricity. That power is then fed quietly to a huge electric motor, which turns the pump jet propeller. Fewer moving parts mean less noise, less maintenance, and a sound that just blends into the ocean's natural background hum. To an enemy listening, the sub doesn't sound like a machine. It sounds like nothing. And then there's the payload. Under her deck, the Columbia has 16 massive launch tubes. Each silo holds a Trident 2D5 LE missile. The LE stands for Life Extended, and these are, to put it simply, planet enders. Each missile has a range of over 7,000 miles and can carry multiple independent re-entry vehicles. This means one submarine, hiding silently and untraceably anywhere in the world's oceans, can strike over 100 different targets on any continent with pinpoint accuracy in under 30 minutes. The Ohio class that came before it actually carried 24 missiles. The Columbia only carries 16. This sounds like a downgrade, but it's not. It's a sign of smarter, more efficient design. The Navy learned that 16 missiles is more than enough to provide a terrifying deterrent, and by reducing the number, they made the ship quieter, more advanced, and more survivable. The missile compartment itself was designed in a historic partnership with the UK, which will use the same compartment for their new Dreadnought class of submarines. What many overlooked is the purpose of this ship. It's not a hunter, it's not an assassin. Its job is to disappear. It will leave port and for 90 days or more, vanish from the face of the earth. Its only job is to stay hidden and wait for a command that everyone hopes will never come. It is the nation's ultimate insurance policy. For a rival power, this is a nightmare. Their admirals know this ghost is out there. They know it could be 500 miles off their coast or just 50. They can pour billions into their own sonar nets, their own hunter subs, and their own spy satellites, but they are searching for a whisper in a hurricane. They are looking for a shadow in the dark. The Columbia class ensures that no matter what happens, no matter how a conflict might start, the United States always has the last word. And that word is devastating. But this doomsday fortress is only half the story. The Navy is also building its assassin, the apex hunter, in its robot swarm. While the Columbia class is built to hide and wait, the U.S. Navy is working on its polar opposite, a submarine built to hunt. It's a purebred predator, an assassin, designed to find and take out the enemy's most valuable ships and submarines right in their own backyard. Right now, it just has a code name, SSNX, or Attack Submarine Experimental. But the X doesn't mean it's just a test, it means it's the next generation. To understand why the SSNX is so revolutionary, you first have to look at its older brother, the Virginia class. The Virginia subs are the current workhorses of the Navy. They are, by any measure, incredible machines. At 377 feet long and weighing nearly 7,800 tons, they are fast, powerful, and very, very quiet. They were designed after the Cold War ended, so they weren't just built to hunt other subs. They were built to be a jack of all trades. The Virginia class has some truly mind-blowing tech. The most famous is the photonics mast. For 100 years, submarines had to use a periscope. This was a long steel tube full of lenses and mirrors that had to physically poke out of the water. The problem? The periscope had to go into the control room. This meant the control room had to be in the cramped upper level of the submarine right under the sail. The Virginia class has no periscope. Instead, it has photonics masts. These are high-tech camera towers that can see in high definition, infrared, and low light. They send their signal through a fiber optic cable. This means the control room is no longer tied to the hull. Engineers moved it down 2 decks into a much larger, more open space. The crew said it was like looking through a tiny straw to watching a giant widescreen IMAX movie. This move also made the sub safer, as the command center is now in the most protected part of the ship. The Virginia subs are also armed to the teeth. They have 4 torpedo tubes for the heavy Mark 48 torpedoes, which are designed to track other subs or break the back of a large warship. But up front, they also have 2 massive 87-inch payload tubes. Each of these tubes can hold 6 Tomahawk cruise missiles. These are long-range weapons that can fly over 1,000 miles to hit a single building on land. A Virginia sub can also use these tubes to launch Navy SEALs in a mini-sub or deploy unmanned underwater drones. It's the ultimate multi-tool. But here's the thing, the world has changed again. The focus isn't just on coastal operations and special forces anymore. We are back in an age of great power competition. The Navy is once again planning for a potential conflict in the South China Sea or the North Atlantic. And for that, it needs more than a multi-tool. It needs a shark. That shark is the SSNX. The SSNX is being designed to take the best parts of all its predecessors. The Navy wants it to have the speed and payload of the old hyper-powerful Seawolf class, the silence and advanced sensors of the Virginia class, and the never-refuel reactor and operational availability of the new Columbia class. It will be a monster, weighing over 10,000 tons, and it will be the quietest and fastest hunter submarine ever built. But its real power won't come from its torpedoes, it will come from its brain. The SSNX is being designed as a deep-sea mothership. This is where the credible fiction part of the plan starts to look terrifyingly real. Imagine this, a conflict is starting in the South China Sea. An American SSNX sits 100 miles away from an enemy fleet, submerged 500 feet deep and making zero sound. Its torpedo room isn't just full of torpedoes, it's a horizontal payload bay, and it's reconfigurable. The sub launches a swarm of 50 unmanned underwater vehicles, or UUVs. These drones are the sub's robot wolf pack. They spread out, communicating with each other on a hidden network. Some are small scouts, just listening. Others are decoys, moving forward and daring the enemy to find them. A few are larger, loitering drones, and they are carrying their own torpedoes. The SSNX itself never makes a sound. It never pings with its own sonar. It just sits back 100 miles away and listens through its drones. Its revolutionary new battle system, powered by artificial intelligence, takes in terabytes of data every second from this entire swarm. It processes the sonar signals, the magnetic signatures, and the water pressure changes, and paints a perfect 3D picture of the entire battlefield for the commander. The AI identifies the enemy's prized aircraft carrier and its destroyer escorts. The commander, sitting in his quiet control room, gives the order. The SSNX doesn't fire a single weapon. Instead, it beams a command to the Wolfpack. 20 miles away, the loitering UUVs spring to life, acquire their targets, and launch their attacks. The enemy fleet is thrown into chaos. They're hit from multiple directions at once with weapons that seemingly came from nowhere. They search frantically for the submarine that attacked them, but there isn't one. The real attacker, the SSNX mothership, is still 100 miles away, totally silent, having already recalled its surviving drones and slipped away into the deep. This is decision superiority. It's the ability to see, understand, and act before the enemy even knows they've been seen. This is the future of underwater war. The SSNX won't just be a hunter, it will be the unseen quarterback of a robotic undersea army. But how do these machines, the Columbia and the SSNX, actually hide? The secret isn't just about being quiet, it's about becoming an acoustic black hole. The science of silence. So how do you make a 20,000-ton, 560-foot-long piece of steel completely disappear in the middle of the ocean? It sounds impossible, but it's a science that the Navy has been perfecting for over 70 years. The bottom line is, you have to defeat the two ways an enemy can find you: active and passive sonar. First, let's talk about active sonar. This is the one everyone knows from the movies. It's the ping. An enemy ship sends out a powerful pulse of sound energy. That sound travels through the water, hits the submarine, and then bounces back to the ship, which listens for the echo. This tells them your direction and your range. It's like shouting in a canyon and waiting for your voice to come back. So how do you beat the ping? You have to stop the echo. Modern submarines, like the Virginia and Columbia, are covered in thousands of special anechoic tiles. These aren't just simple rubber mats, they're high-tech, multi-layered synthetic materials, and they're a top-secret part of the sub's design. Each tile is individually and painstakingly glued to the hull. Their job is to absorb sound energy. When that enemy ping hits the sub's hull, it doesn't bounce off, it gets trapped in the tiles. The sound energy is converted into a tiny, tiny amount of heat and just dies. To the enemy sonar operator who is waiting for a loud ping-ping echo, he just gets bing. Nothing. Just silence. The sub has effectively become a black hole for sound. The hole is also shaped with special curves and angles designed to deflect whatever tiny bit of sound does bounce, sending it away in a random direction, not back to the listener. But here's the thing, most submarine hunters don't like using active sonar. That loud ping instantly gives away their location to every other submarine in the water, including the one they're hunting. So, the real game is passive sonar. Passive sonar is just listening. It's a game of ultimate quiet. The hunter sub and the surface ships just drift, listening with incredibly sensitive underwater microphones or hydrophones. They're listening for the tiniest sound that doesn't belong. The hum of a motor, the whine of gears, the pop of a propeller. This is the real art of silence. And this is where American subs are unmatched. Beating passive sonar means finding every single thing on the sub that makes noise and silencing it. First, the propeller. An old-fashioned, fast-spinning propeller has a big problem called cavitation. As the blade spins, it creates tiny vacuum-filled bubbles in the water. These bubbles then collapse with a small pop. Billions of these pops create a unique humming sound signature. An experienced sonar operator can hear that sound and not just know it's a sub, but know which class of sub it is. The solution is the pump jet propulsor, which all new U.S. subs use. This isn't an open propeller. It's a complex set of blades, a rotor, and a stator that sit inside a large, carefully shaped duct or shroud. This shroud channels the water, smoothing out the flow and preventing those little bubbles from forming. The water is pushed out the back in a powerful but almost silent stream. The sound it does make is at a frequency that is very, very hard to tell apart from the ocean's own background noise. Second, the machinery. A nuclear submarine is a living, breathing factory. It has air conditioners, pumps for coolant, generators for electricity, and CO2 scrubbers for the air. Every one of those machines vibrates. If they were bolted directly to the sub's hull, the entire submarine would hum like a giant tuning fork, sending its sound for miles. To stop this, engineers use rafted machinery. The entire propulsion system, the reactor, the turbines, the generators, all of it isn't even touching the main hull. It's all built onto a massive internal raft or deck. This multi-ton raft is then suspended from the main hull by a series of massive, flexible shock absorbers and acoustic dampeners. Any vibration from the machinery goes into the raft, but it never reaches the outer hull. It can't get into the water. There are other, even sneakier ways to hide. An enemy might not just be listening, they might be looking for a magnetic signature. A huge chunk of metal, like a submarine, disrupts the Earth's natural magnetic field. A plane flying over with a magnetic anomaly detector or MAD boom could spot this. To counter this, subs are degaussed. They are wrapped in electric cables and zapped with a current that resets their magnetic signature, making them magnetically invisible too. And the ocean itself provides hiding places. The water isn't uniform. It's made of different layers of temperature and salinity. A thermal layer, where cold, dense water meets warmer water, can act like a mirror for sound. A submarine commander can dive just below this layer. An enemy ship pinging from above. Their sonar hits that thermal layer and bounces right off. They are completely blind to the sub hiding just beneath it. This level of technology, this obsession with silence, feels like it came from the future. But the truth is, it didn't happen overnight. It was all learned piece by piece during decades of a secret silent war that raged unseen far beneath the waves. This tech was paid for by the lessons learned from the old guard, building the legacy. Before the Columbia, before the Virginia, there was another shadow cutting through the seas. It was older, a little louder, but for its time, it was an unstoppable force. Her name was the USS Los Angeles, and she was the first of a 62 submarines that defined underwater power for a generation. When she launched in the mid-1970s, the world was split in two. The Cold War was at its peak. Every ocean was a chessboard, and Soviet boomer submarines were silently patrolling, holding America's cities at risk. The U.S. Navy needed a hunter that could match them stroke for stroke and depth for depth. The Los Angeles class, also known as the 688 class, was that hunter. She wasn't the biggest, at only 362 feet long and weighing almost 7,000 tons, but she was one of the fastest and quietest of her time. The official numbers said she could dive deeper than 650 feet and go faster than 25 knots. But everyone knew those were just polite numbers for the public. Her real speed and depth were classified, secrets kept only by Steele and the crews who sailed her. This was the era of cat and mouse. This is where the real credible fiction of the movies came from. A 688 class sub would pick up a new Soviet Typhoon or a Kula class sub leaving port and stick to its tail, sometimes for weeks at a time, often deep under the Arctic ice pack. The tension was unbelievable. The American sonar operators would sit in a dark room, wearing headphones, listening for the faintest sign of the sub they were hunting. They were listening for a wrench to be dropped, for a single loud command. They also had to be ready for the Crazy Ivan. This was a famous and feared Soviet maneuver. The Soviet captain, suspecting he was being followed, would suddenly order his submarine into a sharp 180-degree turn to look behind him with his sonar and see if anyone was in his baffles, his blind spot. The American 688 class sub, following silently behind, would have seconds to react, either get out of the way or dive deep, all without making a single sound that would give them away. The Los Angeles class wasn't just one design. The Navy learned and improved it over time, building them in 3 flights. Flight 1 was the original design, pure hunters. Flight 2 was a game changer. Engineers added 12 vertical launch cells in the bow, separate from the torpedo room. These were for Tomahawk cruise missiles. Suddenly, the 688 class wasn't just a sub-hunter, it was a land attack platform. It could sneak up to an enemy's coast and strike targets hundreds of miles inland. This idea was so good, it became a core part of the Virginia class. Flight 3, the last group, was the improved 688 or 688I. These were built to be much quieter, with stronger hulls for operating under Arctic ice. These I-boats were the direct stepping stone to the next generation. What came next was a monster. It was called the Seawolf class. The Cold War was ending, but the Navy wanted the ultimate hunter, a sub that could go faster, dive deeper, and carry more weapons than anything else, including the 688. The result was the USS Seawolf. To this day, it is still the fastest and most heavily armed attack sub in the U.S. fleet. It has 8 torpedo tubes, double the Virginia class, and can carry a massive payload of 50 torpedoes and missiles. Its S6W reactor gives it so much power it's rumored to be able to go faster than 35 knots or 40 miles per hour underwater. But there was a problem. The Seawolf was too good, and too good meant too expensive. Each one cost over $3 billion in 1990s money. The Cold War was over, and the public wouldn't stand for that price. The original plan for 30 subs was cut to just 3, the USS Seawolf, USS Connecticut, and USS Jimmy Carter. The Seawolf program was canceled. This is the lesson that truly shaped the new fleet. The Navy learned from the 688s how to build modular, upgradable subs, and it learned from the Seawolf that cost matters. The Virginia class was born from this. It was designed to be almost as good as a Seawolf, but at a fraction of the cost. It was the smart, affordable, high-tech solution, and the SSSNX will be the child of the Seawolf's power and the Virginia's smarts. The 688 class taught the Navy how to hunt, the Seawolf taught them the limits of technology and price, and the Virginia taught them how to be flexible. All of those lessons are now being poured into the Columbia and the SSSNX. But for the sailors who take these steel ghosts into the deep, this incredible legacy and advanced technology comes at a staggering personal cost: the pressure of perfection. What is it actually like inside one of these machines? For the 150 or so sailors on board, it is a world of total isolation. When a Columbia-class boomer leaves port, it's on a deterrent patrol that can last 90 days or more. From the moment it slips beneath the waves, there is no communication with the outside world. None. To prevent enemies from tracking a signal, the sub maintains total radio silence. They can receive highly coded messages from command, but they can never send one. No emails from home, no news from the outside world, no idea what's happening with their families. Their world is powered by recycled air that has a constant metallic taste from the CO2 scrubbers. The lighting is always artificial, bright white to simulate day and dim red to simulate night to let the crew's eyes adjust for looking at sonar screens in the dark. There is no sun, there is no sky. You see, the machines are built to run for 40 years, but the people are not. That's why the Columbia class, like the Ohios before them, operates with two identical crews, a blue crew and a gold crew. Here's how it works. The blue crew takes the submarine out on patrol for 3 months. They are under constant crushing pressure. They return to port, and the moment they tie up, the gold crew is waiting on the pier. The gold crew takes over the ship, loads its supplies, and within days, they are gone, back out. Sea for their 3-month patrol. The blue crew, meanwhile, goes home to their families, but they also go straight back into training using advanced simulators to prepare for their next patrol. This system keeps the submarine itself at sea for over 70% of the year. The ship never rests. It is always on station, always hidden, always ready. On the attack subs, the Virginia class, life is just as cramped. Many of the junior sailors don't even get their own bed. They hot bunk. This means that 3 sailors working 3 different 8-hour shifts share 2 beds. When one sailor wakes up and goes on watch, his bunk is still warm, and the sailor coming off watch immediately climbs into it. Privacy is a word that doesn't exist. You eat, sleep, and work inches away from the rest of the crew, and the pressure is constant. Every single person on that sub, from the captain to the cook, knows that a single mistake could be catastrophic. Dropping a heavy wrench, closing a hatch too loudly, shouting in a passageway. These are sounds that travel. A single careless noise could be the one thing that gives away their position to an enemy hunter, getting the entire crew detected. So, as we look at all this, are we missing a key detail? Is this level of technology even real? Many people are crazy about these specs, and they seem to border on science fiction. The thing is, this is all very real. It just didn't happen overnight. It's the result of billions of dollars and decades of secret research. It's the work of hundreds of thousands of engineers and sailors, all focused on one single goal: silence. What many overlook is the final strange truth of these terrifying machines. The Columbia class, the most powerful weapon ever built, is created with the single fervent hope that it never ever has to be used. Its entire purpose is to be the silent, unseen guardian that makes the cost of a war too high to pay. It's a weapon of peace, built on the terrifying promise of total destruction. It's the ghost in the machine among the guides, and its silence is the loudest sound in the world. That's all for today, but here's the controversial question. Does building a more silent, more powerful weapon actually make the world safer, or just make the stakes of the next conflict terrifyingly higher? Let us know your thoughts below. Don't forget to like and subscribe.